For the purpose of this demonstration, we'll be focusing on how mathematics can be incorporated into Year 2 science.
Before we begin, let's review the general capabilities found in the Australian curriculum. As we know, there are 7 general capabilities: literacy, numeracy, ICT capacity, critical and creative thinking, personal and social capability, ethical understanding, and intercultural understanding. These components were chosen with the purpose of guiding students to be a successful learner, confident and creative individuals, and active and informed citizens.
Each of these general capabilities are further broken down and addressed within the content descriptors, which provide examples to teachers on how they can deliver their content to the students. Each content descriptor will have one or more icons associated with it. These icons are used to show how the general capabilities can be incorporated into the content descriptor. If the general capabilities were not included within every curriculum aspect, then students would fail to comprehend what they are being taught. For example, mathematics should not be seen as separate or divorced from other areas of learning, as making links to other curriculum areas allows students to see how the skills they are learning in mathematics are relevant to other areas of study. The same can be said for the other 6 general capabilities: literacy, ICT capacity, critical and creative thinking, personal and social capability, ethical understanding, and intercultural understanding are all integrated within the aspects of the Australian curriculum. The general capabilities play a significant role in the Australian curriculum in equipping young Australians to live and work successfully in the 21st century. They support the development of numeracy for the common good by ensuring that students are given the knowledge, ability, and skills to be confident members of society later in life. Without a wide range of mathematical concepts and skills, they will find they are unable to easily function with everyday problems or contribute to their community. Now let's focus on numeracy. It is broken down into 6 key ideas: estimating and calculating with whole numbers, recognizing and using patterns and relationships, using fractions, decimals, percentages, ratios, and rates, using spatial reasoning, interpreting statistical information, and using measurement. Using the learning area specific advice for science, I was able to identify the mathematical content that is evident in science. I then took this a step further and broke the content up into 6 key ideas for numeracy to emphasize how science and mathematics can be intertwined. Within estimating and calculating with whole numbers, I was able to find the use of mathematical relationships to calculate and predict values, and the use of mathematical tools to provide evidence in support of hypotheses or positions. In the substrand recognizing and using patterns and relationships, I found that as students progress, they collect qualitative and quantitative data, which are analysed and represented in graphical forms. Students learn data analysis skills, including identifying trends and patterns from numerical data and graphs. The interpreting statistical information substrand finds that in later years, numeracy demands include the statistical analysis of data, including issues relating to accuracy and validity. The using measurement substrand for science includes students are introduced to measurement, first using informal units, then formal units. Later, they consider issues of uncertainty and reliability in measurement. I was then able to take this a step further. Using the Australian Curriculum Year 2 Science and Mathematics year level descriptions and achievement standards, I have compared and identified the mathematical content that is within the science strand. As seen from this table, the mathematical key ideas have also been acknowledged. For the year level description, Year 2 Science have that students learn to reveal patterns, make predictions, and use counting and informal measurements to compare objects, while Year 2 Mathematics have students learning to describe relationships between objects, use the language of chance to describe outcomes, connecting number calculations and counting sequences, as well as using informal measurements to compare measurements. The achievement standard for Year 2 Science states that by the end of Year 2, students will be able to describe changes to objects, materials, and living things, use informal measurements to make and compare observations, record and represent observations, and communicate ideas in various ways. Whereas the Year 2 Mathematical Achievement Standard has students at the end of Year 2 describing outcomes for everyday events, order shapes and objects using informal units, collect, organize, and represent data to make simple inferences. As you can see from this table, both science and mathematics are intertwined. Looking at numeracy, it is broken down into content strands and substrands, as well as proficiency strands. The first content strand is number and algebra, and these include the substrands of number and place value, fractions and decimals, real numbers, money and financial mathematics, patterns and algebra, linear and nonlinear relationships. The second content strand is measurement and geometry. The substrands include using units of measurement, shape, geometric reasoning, location and transformation, Pythagoras, and trigonometry. The third content strand is statistics and probability, with the two substrands being chance and data representation and interpretation. The four proficiency strands are understanding, fluency, problem solving, and reasoning. According to Rees, these strands provide the language to build in the developmental aspects of the learning of mathematics and have been incorporated into the content descriptors. I've chosen two content descriptors from the Year 2 Science curriculum under Science Inquiry Skills. The first one being substrand planning and conducting. Use informal measurements to collect and record observations using digital technologies as appropriate. The second is from substrand processing and analyzing data and information. Use a range of methods to sort information, including drawings and provided tables, and thorough discussion. Compare observations with predictions. With these content descriptors, I'll show you how students would be required to use their mathematical knowledge, skills, and strategies in an activity. For the first content descriptor, use informal measurements to collect and record observation using digital technologies as appropriate. Students can be given a list of items around the classroom they need to measure using everyday objects from around the room, such as a book, a pencil case, or a pencil. They can then present their findings in a table to be able to compare the size of objects provided using their chosen measuring item. This science content descriptor is using the numeracy key idea of using measurements, where students are introduced to measurement, first using informal units, then formal units. The second content descriptor use a range of methods to sort information, including drawings and provided tables, and thorough discussion, compare observation with predictions. Could include an activity where the whole class has performed an experiment, and then individually or in groups, students must sort and compare the results. In this example, students were given a table comparing two different plants and how many days it took to grow. This was then transformed into a bar graph to help with comparison and can also be used to confirm or deny original predictions. This science activity can be used in more than one of the numeracy key ideas. First off, it can be slotted into using measurement, as well as recognizing and using patterns and relationships. This is where students learn data analysis skills, including identifying trends and patterns from numerical data and